Let's do some more cool stuff with the Effect AI package. Something that I think would be really cool for us to do is to use the AI language model's generate object method to get back a description of a schema, which we can use to hydrate an actual effect schema, and then use that effect schema in another generate object call. So effectively have the language model tell us what type to ask it for. In other words, metaschemas. We'll start out by creating a type that represents what the language model is going to give back to us initially. Type schema spec equals either null, Boolean, integer, number, string, array. In the case of it being an array, it's going to be able to specify the item type. So that'll be schema spec object. The entries of the object to be read-only array, wherein the key is a string and the spec of the given entry is the schema spec. Or a union, wherein the members are read-only array of schema spec. And this represents the data that we're going to want to get back from the language model in order to hydrate an effect schema, and then use that schema to query the language model for an instance of that type. So let's create the runtime representation of this using effect schema. First off, we'll bring in schema from effect. This is going to be a union type. Let's scroll a little bit. We'll use schema.tagged struct to make our lives a little bit easier. The first is null. The second is Boolean. The third is integer. The fourth is number. The fifth is string. The sixth is array. This has item on it. And you'll notice that if we were to use schema spec here, we run into a use before definition error. So we're actually going to use schema.suspend, which takes in a function referencing another schema. And then we run into this circular reference error. We can solve this by adding an explicit type annotation with the schema spec type that we declared above. We're still getting an error because we have yet to create array and union variants. So let's do that. Create another schema.tagged struct with object as the tag. It has entries, which is a schema.array of schema.struct, wherein the key is the schema.string, and the spec is the same as in array. So why don't we actually extract this out? We'll call it suspended schema spec. Then we can take this type and paste it right here. Let's add our final member of this union, a tag struct with the tag union, and members as the schema.array with the suspended schema spec. And just like that, the type error from above goes away because the schema spec now conforms to the type that we laid out. One other thing that we might want to do is force the language model to describe the type that it's giving us. So let's go back up to our schema spec type. We're going to wrap this and intersect all of these members of the union with an object that contains a description. In the schema definition, we can type schema.extend, schema.struct, and then give it the field description string. Finally, let's annotate our schema spec with an identifier. This will ensure that when serialized to JSON schema, it has this named reference to itself. Let's scroll down a little bit. We'll create a program with effect.gen. We need to import effect. We'll then access an AI language model instance. This comes from the Effect AI package. Next, we'll go ahead and use the model's generate object method and give it a prompt wherein we tell it to spec out a complex object type that encapsulates the information of a fictional story world full of magic and wonder. Let's just clean this up a little bit. And we'll give it our schema. On line 59, we could actually just destructure the world schema directly out of it. And this should give us that type that we described above. Now we're going to need to create a function that takes in this schema spec and outputs an actual effect schema. We'll create a function called toSchema. This will take in our schema spec, and it will output a schema of any. Within here, we're going to switch the spec tag. In a case of null, we can return schema.null. In a case of Boolean, you return schema.boolean. In the case of integer, we return schema.int. In the case of number, return schema.number. In the case of string, return schema.string. In the case of array, return schema.array, and recursively call toSchema with the spec.item. In the case of object, return schema.struct. And here we'll create a new object from the entries made from mapping over the entries using the entry key and recursively calling toSchema with the entry spec. Finally, we deal with the last possibility, a union. Return schema.union, and then pass in the spec members mapped to schema. We can now go down to our program, get the world schema by calling toSchema with the world schema spec, and this provides us with an effect schema. And then get another response describe a fictional story world of magic and wonder. And this time, the schema that we provide is going to be a struct containing the world, which is the world schema. We'll grab this value from within here. And just to make sure it's working, let's maybe yield some console. This is from effect, console.log. JSON.stringify, world schema.ast, null2. And let's do another console log, JSON.stringify, world, null2. So a quick summary of what we're doing. We're asking the language model to give us a schema spec. We take that schema spec and we turn it into an effect schema. We take that effect schema, which then gives us a value of that schema type. Before we can run it, we need to provide the necessary dependencies to our program, namely an AI language model. We'll create a layer, bring in the layer namespace, get an empty layer, and then let's pipe into it, layer.provideMerge within OpenAI language model dot model. For a mini, we'll layer.provideMerge with the underlying OpenAI client made from a layer config with an API key. Config also comes from effect dot redacted and the name of the environment variable. The last layer that we need to provide is a fetch HTTP client. And that gives us the layer that we should be able to provide to our program. And finally, effect.run promise, and we'll await it. Maybe one other thing that we'll do before running, just so that it's a little bit easier to read, when we're logging out the AST of the schema we get back, let's actually not JSON stringify it, because we do want for it to truncate in the console so that we're not looking at too large of a tree. This should be to JSON, and that'll be a little more legible when we log it out. Oh, and the last thing that we're going to want to do is go up to schema, and actually we need to attach the description to all of these types. So let's create an initial. This will be an immediately invoked function expression. We're going to copy everything we have here, paste it in there, and then return initial.annotations description spec.description. And this will ensure that when we ultimately pass it into the generate object, that the language model has a schema that is annotated with the descriptions that were established by the language model call before it. Let's run it. So we get back this AST that describes the different fields within the type that we're ultimately asking for. And then we get an instance of that type. It has a description, it has a magic system, it has different races, it has certain geography, it contains regions, notable locations, it seems there are factions, legends. And so, yeah, we just gave the language model the ability to describe a type in a structured way, so that we can then use that type for even more interaction with the language model. I hope you enjoyed this video, and thank you for watching.